Each dataset brings its own challenges. Some have outliers, noise, missing values, some need encoding, or some require scaling. I already covered most of this in earlier videos. If you haven't seen those, just scroll through the channel and check them out. Today, we will focus on label encoding, dummy encoding, scaling, and removing duplicates. Let's get started with label encoding. We have many encoding methods, contrast encoders, Bayesian encoders, cat boost encoders, but for now we focus on classic encoders, ordinal and one-hot encoding. Remember, the method you choose depends on your data and model. You don't need to learn all of them. So, converting columns. In the heart disease dataset, features are numerical. Let's convert one of them to categorical. So I chose the sex column into a categorical type to test encoding. This method replaces F and M, female and male, with 0 and 1. This type is also called ordinal encoding, and it works well for tree-based models. In scikit-learn, encoding is done in 3 steps: initialization, fitting, and transforming. Or after initialization, in fitting, it learns the unique categories, and then in transforming, it converts categories to numbers. From scikit-learn, we bring the preprocessing packages and import the label encoder. The label encoder is equal to ordinal encoding. So you can see it convert the categorical values to number. In dummy encoding, pandas offers get dummies to one-hot encode the categorical features. It turns one column into binary columns, and to avoid multicollinearity and redundant info, it's better to drop the first column with drop first equal true, and to detect and preserve missing values, we can add dummy NA equal true. When to use label versus dummy encoding. Label encoding is simpler and keeps one column. It's good for tree-based models. One-hot encoding can work better for distance-based models like Kynen or SVM, but it adds more columns and can make the data sparse. So choose based on your model and the nature of your features. After encoding, we move to scaling to normalize the values of features. Because features like age, cholesterol, and heart rate, in this case, we have very different ranges, which can harm model performance. To be more clear, comparing a banana with an orange. If the units are different, the model might get confused. So we have to bring them to the same scale. The most common method is min-max scaling. The formula is xi minus mean over range. In scikit-learn, again, we follow the 3 steps: initialization, fit, and transform. So here from scikit-learn, again, we use the preprocessing packages and we import min-max scaler. Now all features are scaled between 0 and 1. Next, we check whether a feature like ca is balanced or has noisy categories. We use value counts to count how many of each category exists. If the total doesn't add up to 597, we know we still have missing values. By adding drop na equal false, force it to show the nulls. For example, if category 9 is considered noise, we can replace it with 0 using this trick. As you can see, we choose the whichever is equal to 9, change it to 0. As you can see, the value was added to the 0, and now it is 180. So in the next, duplicate rows. Whether in terrain or test can cause your model to overfit. If it happened in terrain, it learned from the same data more than once, which cause to remember data, and if it appear in terrain and test, make model overfit. So duplicates means every columns include the label is repeated. So let's do find and remove them. We can find duplicates with df.duplicated method. And to remove them, we can use df.drop. You can also keep the first or last duplicate, or view all of them by choosing keep equal false. Now data is ready for modeling. Thanks for watching, and please like and subscribe my channel.